Right, so this set of videos is going to talk about chemical reactions. So we're going to talk about what they are and how to read them, balance them, and the different types of reactions that are related to what you guys might be working with. So first, chemical reactions. What are we talking about here? We're just talking about different atoms being put together. So in any chemical reactions, atoms are going to be rearranged to create one or more new compounds. So you can see down here, we've got hydrogen gas and oxygen gas. So these guys are going to be basically taken apart, put back together so that they can form water. So that's all we're doing here are different reactions with these atoms interacting with each other and rearranging to make one or more new compounds, or sometimes they're actually being torn apart to make those new compounds. So we do write them as chemical equations. So you can see an example of that down here. So we use the chemical formulas. So the atomic symbols with the subscripts to show us who is there and how many of them. Obviously, a plus to show that they're being added together. And then the arrow is showing us the direction of the reaction. So whichever way the arrow is pointing, that's the way that we're going as far as the reaction goes. So anybody on the side that the arrow is pointing away from, we call reactants. So those are the ones that are being put together or taken apart. And then the arrow points towards the products. Who is going to be made from that reaction? So this is what we call a balanced equation. I'll talk about that here in a minute. So let's take a look at this equation. So the last equation was making water. This equation is making carbon monoxide, just CO. If you're wondering about these symbols right here, if these show up in an equation, so they're parentheses after a chemical formula with letters in them, those are showing you the phases that those compounds or elements are in. So solid, gas, L for liquid. There's also one that shows up that is AQ. So if you see one that is AQ, this means that it's dissolved in water. So just so you know, if you see these, that's what those are. So you can kind of ignore those if they show up anywhere. I put them in here so that you knew what they were if you see them in like practice places that you might go and look at. So taking a look at this equation, we need to talk about the law of conservation of mass. So the law of conservation of mass says that things can't be created or destroyed. It's kind of like the laws of thermodynamics. We can't, create or destroy energy. Same thing for matter. Matter is always conserved. So you cannot gain or lose atoms in a reaction. They can't just disappear and they can't just appear. So, for example, in this equation, we have a problem. All right. So the problem with the above equation, we have two oxygens that we started with, but there's only one over here. And so basically what this is saying, the way it's written, is that one of these oxygens just up and disappeared. It ran away. And we can't have that happen. The law of conservation of mass says you can't have things just appear and disappear. They can't do that. Can't gain or lose them during a chemical reaction. So basically what we're saying is that the mass or number of reactants has to equal the mass or number of reactants. Okay. So what can we do? How can we fix this right here? And this is where balancing equations come in. If you've ever remember doing this in school, this is why we balance equations. It fixes this problem of atoms just appearing and disappearing. Okay, so if we get our equation back again, so we've got 1 carbon, 2 oxygens, and then a carbon and an oxygen on the product side. How are we going to fix the equation? A lot of people just want to either cross this out or put a 2 over here. And the problem is that we can't do that. We can't alter the subscripts. And the reason why is, first, oxygen can't be by itself. You can't have a single oxygen atom. It has to have 2. You have to have O2 because if you remember from previous videos, oxygen has to have that full valence shell. It has to have 8 electrons in its outer ring. And the only way to do that is to have shared electrons with somebody else. In this case, it's sharing electrons with another oxygen. So we have to have 2 oxygens on this side. So that has to stay the way it is. We can't put a 2 over here because this compound that we were making is this guy. If we put a 2, then what we're making, oops, sorry, that one, is this. 2 very different compounds. All right, carbon dioxide, this is the one that plants use. It's decently harmless to us. It's one that we breathe out, but as long as, you know, we have oxygen around, we're fine. This one, carbon monoxide, if you recognize its name, this is the one that can kill us. This is the one that can bind to our red blood cells. So very different properties from the other. So definitely want to make sure that we don't alter the subscripts because that alters the materials. So that's why. So instead what we do is we put what we call coefficients in front of the chemical formula to balance it. So remember, this little guy, the subscript, shows you how many oxygens there are. So what we can do is put coefficients in front of the chemical formulas in order to add more of each of those materials. So if we take a look at what I'm talking about with some pictures, so just the C is for 1 carbon atom, right? Just O would be 1 oxygen atom, and we know that can't work. But O2, the subscript, is an oxygen atom, or an oxygen molecule, so that works. That's what we need. CO means these guys, right? So we've got our carbon monoxide, that's what we want. Carbon dioxide, CO2, is this guy I showed you before. We don't want to make that, but we can use it to show what a coefficient is. So the coefficient is the big number you put in front, and so when you do that, it's showing that we would make 3 of those carbon dioxide molecules. So if we put a 3 here, then we would have 2 more of these guys. So 2 more carbons, 2 more oxygens to make up the 3 carbon monoxides. All right. So we bring back this. So how do we fix our equation up here? Well, we know we have 2 oxygens on this side. So to fix it, we put a 2 a coefficient of 2 in front of carbon monoxide, because now this is going to make 2 of everything that follow it. So it makes 2 oxygens, 2 carbons. Well, now we have too many carbons, so we put a 2 in front of the carbon on this side, and that gives us our balanced equation. Because now if we look at it, 2 carbons, 2 carbons, 2 oxygens, 2 oxygens. So no missing atoms on either side. All right, so the next video, I'm going to walk through how to balance equations, because this is something that you'll need to be able to do. So I'll pick up in the next video with balancing equations and doing some practice.